Okay, Echo, so I'm going to go over the first couple examples and just kind of walk you through it to show you how this is done. So here is example letter A, FeCl3. Okay, so the first thing that I do is I'm going to count each element on each side. So usually I just make a list, so we know that there's ferrine, there's iron, we know that there's chlorine, and on this side we know that there's iron and there's going to be chlorine. So the elements are going to be the same on both sides. And so then I count. On this side there's only one iron, and on this side there's one iron. On this side there's two chlorines, okay, that's what the 2 indicates. And on this side there's 3 chlorines. So we know that this equation is not balanced because we have 2 chlorines on this side and we have 3 chlorines on this side. So the first thing that I'm going to do is I'm going to change things a little bit in order to figure out how to get the answer that I need. So I'm going to start, since right now iron is already even, I'm going to go on and I'm going to play with the number of chlorines. So I know that 2 and 3, that they are both divisible into the number 6, right? So that's going to be a common number that we can look for. So 2, if I divide 6 by 2, that would give me 3. So I'm going to start right there. So if I put a 3 there, now I still have 1 iron on the side, but now I have 6 chlorines. But I'm still not even because I only have 2 chlorines over here, or 3 chlorines over here. So if I want to make this 3 into a 6, 6 divided by 3 would be 2. I'd have to put a 2 there. So that would give me 3 chlorines times 2. I've got to take 3 times 2. So that would give me 6. So my chlorines are even, but I added an extra iron in here. And so now my iron is 2. So now my chlorines are balanced, but my irons aren't balanced. So what can I do over here to get 1 more iron? Well, I can put a 2 here. And now I have 2 irons. I have 6 chlorines on this side, and I have 2 irons, and I have 6 chlorines on this side. So the balanced equation would be 2 irons plus 3 chlorides will end up giving me 2 molecules of iron chloride. So count each individual element first, and then kind of play around with the numbers to see if there's something that's going to work. Let's try letter B. So we got, again, iron plus oxygen gas, which is going to give us iron oxide. Okay, so again, list out all of the elements. We have iron, we have oxygens, we have iron, this should be Fe, sorry, and we have oxygen. Count them up. There's 1 iron on this side, there's 2 oxygens on this side. On this side we have 2 irons, and we have 3 oxygens. So, what can we do? Let's start with, again, let's look at the oxygens here. Okay, we know that 2 and 3, if we multiply those together, that would give us 6, so that's kind of a common number. So in order to get 6 oxygens, we would have to put a 2 here. And then we would have 6 oxygens, and we would now have 4 irons. But we're still not balanced. So then over here, in order to get 6 oxygens, we could put a 3 here, 3 times 2. That will give us 6 oxygens. But our irons aren't balanced. There's 4 over here, and there's only 1 here. So I can just easily add 4 irons there, And now I have 4 irons on this side, I have 4 irons on this side, 6 oxygens on this side, and 6 oxygens on that side. I want to show you one other quick example that involves a polyatomic atom. So let's see, what example on your worksheet would this be most like? Well, let's just do the next one, letter C. Okay, so I have FeBr3 plus H2SO4, which is going to make Fe2 SO43 plus HBr. Okay, so here's a polyatomic compound. So we have to treat this one a little bit different. This 3 means that there's 3 of these. So like if we were to draw it out, there'd be SO4, SO4, 1, 2, 3 of those. And so we have to count all of the elements that would exist in there. So here's how this would work. Again, list your elements are. We got iron, we got bromine, we got hydrogen, we have sulfur, and we have oxygens. And we're going to have the same ones on this side. Iron, bromine, hydrogens, sulfurs, and oxygens. Okay, on this side we have 1 iron, we have 3 bromines, we have 2 hydrogens, we have 1 sulfur, and we have 4 oxygens. On this side we have 2 irons, we have 3 sulfurs, right? There's 3 of these SO4s. That's what this means. So then we would take 3 times 1 sulfur. We would take 3 times 4 oxygens. Oops, that would be 12. Sorry, 3 times 4 would be 12. Okay, so when you look at this polyatomic, you got to take this number and you got to multiply by each one of the individual elements. So 3 times 1 sulfur is 3. 3 times 4 oxygen is 12. And then over here we have 1 bromine and we have 1 hydrogens. Okay? And so let's just go down the line. So for iron, we have 2 over here and we have 1 here. So we're going to add an iron over here. That's going to give us 2 irons on this side, and it's going to give us 3 times 2, 6 bromines. So let's come over here. Our irons are even, but now our bromines are not. So there's only 1 here, there's 6 here, so we're going to add a 6 over here in order to give us 6 bromines, but that also gives us now 6 hydrogens. All right, so our irons are balanced, our bromines are balanced, our hydrogens are not. There's 2 on this side, but there's 6 on this side. So how do I get this hydrogen to be 6? Well, if I have 2 on this side, I can multiply that. I can add a 3 there. That's going to give me 3 times 2, 6 hydrogens. It's going to give me 3 times 1, 3 sulfurs, and it's going to give me 3 times 4, 12 oxygens. So now my hydrogens are balanced, 6 on this side, 6 on that side. I have 6 sulfurs on this, or 3 sulfurs on this side, and I have 3 sulfurs on that side, so that one's balanced. And I have 12 oxygen on this side, and I have 12 oxygens on that side, so that one's balanced. So here's the balanced equation. Hopefully this is helpful for you. Let me know if you have any other questions as you go through the worksheets. Why don't you skip letter I? That one's pretty difficult. It's big numbers, but you should be able to work through the rest of them.